Okay, I'm going to go over testing with analysis of variance. And the data set that I have is very similar to the type of data that you would see on the exam. And I'm trying to give you practice of doing this without calculating things from scratch. So we're going to go ahead and use information that has already been obtained. This is where it gets very important. When you read these research scenarios, you need to carefully go through and kind of pull out information that is important. For example, I have, if you notice, it's talking about basically drug addiction, and they have a sample of 8 alcoholics, and I'm going to highlight here, 8 smokers, and 8 heroin addicts. Okay, now I know some of you might not think that smoking is a drug addiction, but it actually is. Nicotine is a drug, and it is addictive. So those are our groups. So well, technically you can be an alcoholic, a smoker, and a heroin addict all at the same time, but they are specifically stating they obtained a sample of 8 alcoholics, 8 smokers, and 8 heroin addicts. So those are 3 different samples with different people in each of those samples. So the total amount of people that they had was 24, because they have 3 different groups. Now they also give us some other important information. They were looking at how long they had remained abstinent. So that's basically our dependent variable, the number of days abstinent in days after their first treatment. Then they also talk about averages. The results showed the average number of days abstinent was 133.75 for alcoholics, 107.13 days for smokers, and 108.75 days for heroin addicts. So this is all information that is very important to be able to conduct the ANOVA. Now, the fact that these are different people in each of these groups, and there's more than 2 groups, is the reason why we're running a one-way ANOVA. So we have a 0.05 alpha level, so we know the alpha level that we have. Now, the key here is, if you notice, this is basically the beginning of an ANOVA table. So if we were to carry over our table, it would actually end up looking like this. So you'll see you were given a portion of the table. So here is, and this part is your DF, degrees of freedom. Here is, mean square or your variance, and this is your F. We don't need this, we don't need this, and we don't need this. So this is what you kind of want to look for. You've been given the hard parts. You've been given your sums of square between groups, your sums of square error. Now you need the total. And remember, if you use your table, you can go through all of this very easily. But first and foremost, let's kind of start with step 1. So we want to state our hypothesis. Basically, we need to indicate, okay, what is our dependent variable? That's the days abstinent. And what is our independent variable? It's a type of addiction. So what we do is we write our alternative. Days abstinent will differ between, let's see, we have alcoholics, smokers, and heroin addicts. So From this point forward, you really only need to worry about your alternative hypothesis. And we're going to test this at 0.05, alpha level 0.05. To be able to get our critical boundary, we need to get our degrees of freedom. So if you remember, degrees of freedom for between groups, so I'm going to highlight that. Our degrees of freedom for between groups is k minus 1. So I'm going to go back and we're going to go kind of color code it. Degrees of freedom between groups equals k minus 1. That's basically how many groups do we have minus 1? Well, we have 3 groups, and we subtract 1 from the number of groups that we have, and that's 2. So our degrees of freedom for between groups is 2. Now, we need to get our degrees of freedom for the error group, which is also known as within. So degrees of freedom for error. Okay, I'm going to use my highlighter real quick so you can see that we're dealing with this right here. So to get the degrees of freedom error, it's capital N minus K. Now in this case, capital N is 24 because if we have 8 alcoholics, 8 smokers, and 8 heroin addicts, we add those 3 up, and that's 24. So we have 24 minus, and if you remember, K is 3. A big error that people usually make is putting 2 there because they use the degrees of freedom from between groups rather than the actual K. So when we get our degrees of freedom error, we go 24 minus 3 and we get 21. Now we can verify our information. If we go degrees of freedom total, that is capital N minus 1. Well, 24 minus 1 is 23, right? So we can put 23 here. If you add up 21 plus 22, you get 23. So you can see that your degrees of freedom between groups and degrees of freedom error was correct because they should all add up. So now we have the information that we need to go ahead and complete our, I'm going to erase down here, to complete our step 2, which is finding the criteria. Okay? So we're going to look up the between groups and the error degrees of freedom. Now in your textbook, that's in the F distribution, and that is in table C3. And is what you do is you look up 2 for the degrees of freedom numerator, which is that top row. And then in the first column it says degrees of freedom denominator. That's where you're going to look up 21. And we're using 0.05, so you're going to use the light face. So if I look up 21 and align it with the 2, my critical value is 3.47. So F critical value equals 3.47. So that's a positive. Remember, ANOVA is always positive. So is what we're looking at is this, 3.47. Anything in the tail out there is significant at 3.47. So let's move forward. I'm just gonna transfer some of this over so that we have the information. Our critical value was 3.47. Well, 4.76 is right here, or 4.77 really. So it is significant. So back here and look, we have our 4.77 falls within that critical region. So we are significant since our critical value is 3.47. To the next page, if you remember, I'm going to continue this. Maybe I'll get it a little neater this time. So df, and then we have mean square, and we have f. Okay. We have 2, we have 21, and we had 23. And this was our ooh, sorry. Let me fix my mess I've created here. Okay, this is our total. Okay, so we're going to need our mean squares and our f. Now, the first thing we want to do is go ahead and get our total. Is what we do to get that, our sums of squares total, which is this right here. You guys get the easy way. You're just going to add your sums of square between groups and your sums of square error. So, is what I'm doing is I'm putting in my calculator 3,564.08 plus, oops, I'm sorry, yeah, plus 7,845.88, and that will give us our total. So I ended up with 11, that's not the right one. I need the correct pen. Okay, 11,409 and 96. So there is like a period there. So now we can actually start doing the other calculations. So the nice thing about the ANOVA table, if you just use the ANOVA table, you can easily work through and get your F. Once you have your degrees of freedom and all of that, you can easily get the information you need. So I'm going to show you what I'm doing in blue, basically. I'm going to take a division symbol and put right here, and then I'm going to put a division symbol and put it right here. An equal sign here and an equal sign here. Because that's really all we're doing. Okay, remember we don't need any of this. So, if I do 3,564.08 divided by 2, that gives me 1,782.04 for my mean square. And then I'm going to do 7,845.88 divided by 21, which is 373.61. Now, this is the nice part about the ANOVA table. It makes everything so simple because now that I have those, I'm going to just use this as a division. So mean square between groups is in the numerator, mean square error is in the denominator. So I'm going to take 1,782.04 divided by 373.61, and that gives me my F obtained, which is 4.77. So we have F obtained equals 4.77, and if you recall, we'll go back, that means we have more to do. Well, we would have more to do anyways. We would have an effect size, but we also will have post hoc tests. But before we get to post hoc tests, let's do our effect size. Now, our effect size is eta squared is what we use for effect size. Bear with me one second because I'm trying to get my calculator unfrozen. Okay, got it. So our eta squared, which is our effect size, is going to take our sums of squares between groups and divide it by sums of squares total. That's why it's important that you get both. So you're basically taking this number here and dividing it by this number here, the top by the bottom. So we end up with 3,564.08 divided by 11,409.96. So then our eta squared, let's see, is 0.3124, or 0.31 is fine. That's our eta squared. That's our effect size. Now, because our test was significant, we need to conduct post hoc tests. So, to conduct our post hoc tests, we need to use our means, and we need to use our a new critical value. So I'm going to move forward one more page. Back. Our mean square error is 373.61. We have that basic information, but I'm going to write here our F equals 4.77. Our eta squared equaled I think it was 3.1. Just so we have that information. Okay, now, if we look, we have been provided our means. So we had alcoholics were absent at 133.75, smokers 107.13, and heroin addicts 108.75 days. So those are the means, and we're going to need those to do post hoc tests. Now, the obtained test statistic for F just tells us somewhere there is a significant difference. Somewhere within all of this information is a significant difference. It just doesn't tell us where. So, with that, we're going to do post hoc tests. Oops, that's not what I wanted. Okay, so our post hoc tests, we are going to be using what's called a Tukey. And it's a Tukey HSD. Now, Tukey HSD can only be used with equal sample sizes. You'll notice it's Q, and then we have a square root, MS, error divided by sample size, okay? Well, the N, the sample size is a lowercase n. It's telling us how many people we have in each of the samples. So we're going to have, I'll write this, 8, because we have 8 people in each of the samples. We need to get our mean square error. So 373.61, all under the square root, but then we need to find this Q. And that's where it gets a little complicated. So we need Q. Q is actually found in the back of your textbook, and it is a critical value. And so it's after the F distribution. You actually need to go to the next table, which is table C4. And at the top it should say the studentized range statistic, Q. And now you have, at the very top it says range, and on the left column it says degrees of freedom error. So now you're going to use range, which is K, which K is 3. If you remember, we have 3 groups. So we need to look at, I'm going to put here, K equals 3, and then we had a degrees of freedom error, and if you recall, that was 21. So this is the information we're going to need. And remember, we're using 0.05. So in the top row, you line up 3, and then you go down. And if you'll notice, there it goes from 20 to 22. What I did is I just took the average. So I did 3.58, which was 20, plus 3.55. And then I added those together and divided by 2 just to get that in between number. So my Q that I ended up with for that critical value, I ended up with 3.565. So now we have everything that we need to calculate this. So I divide 373.61 by 8, take the square root, and multiply that by 3.565. And I end up with 24.3627. So this is basically our mean difference that we're going to be comparing our means to see if those mean differences are larger than 24.3627. So is how I do that is, again, I'm going to come up here and I'm going to put HSD equals 24.3627, so we can remember that. Now again, here's our means, and I shouldn't be scratching them out, I should be highlighting them for us. So 133.75 for alcoholics, 107.13 for smokers, 108.75 for heroin addicts. Basically, is what I'm going to do is calculate their differences. So is what I do is mean 2 minus mean 1. So that's 133.75, 3 point, let me write that normally, 0.75 minus 107.125. Because I put, like, this is group 1, this is group 2, this is group 3, is how I have it. And it doesn't matter too much as long as you're understanding what makes sense. So the difference between those is 26.625. Now we want to compare that to 24.3627. Well, that is bigger than. So we have significance between these two groups. So I'm going to click this as red. This is where we have significance in one of those. Now I'm going to take group 3, mean 3, minus mean 1, because we're going to do all the potential differences, which is 133.75 minus 108.75. And if we take that difference, that's 25. Well, we need to compare that to 24.3627. And if you'll notice, 25 is larger. So we have significance between those two groups. Now I'm going to take the last combination, mean 2 minus mean 3. Now, what I do is I always just plot it whichever number is bigger so that there's never negatives, because it's actually the absolute value is what you're looking at. So I just take whichever group number is bigger and subtract that smaller one. So we have 108.75 minus 107.125. And that is a difference of 1.625. Now, again, we're going to compare that to 24.3627. to 7. And pretty obvious, 1.625 is less than, so it's not significant. So now we need to kind of make sense of this and be able to report those results. So we know the overall ANOVA is significant, and then we know that the post hoc tests are showing between group 1 and then group 2 and group 3. So is what we need to do is make sense of it. So is what we're actually going to do is write our overall ANOVA results first. So we're going to look at this. So if you notice these two groups that are significant, so this one and this one, both of these have group 1 in common. So if you notice, these two have group 1 in common. So if we really think about it, the number of days that for group 1 for alcoholics, right, was significantly more days abstinent than smokers or heroin addicts, because 133.75 days is larger than 107 days or 108 days. So basically is what it's saying is alcoholics were able to stay abstinent much longer than smokers or heroin addicts. This is based off of real data. It is actually found to be harder to quit smoking than any of the other addictions. Probably partially because it's more socially acceptable than heroin, I'm thinking. But it is a very difficult one to beat. So with that being said, we've made a separate page here, so that we can write our APA results. So there's actually two results here. You have your overall result, and then you have your post hoc test. Now, if this test was not significant, we would have never done post hoc tests. The only reason we did post hoc tests is because the overall test was significant. So I'm going to write ANOVA showed a significant difference in days abstinent between alcoholics, smokers, and heroin addicts, as, this is all one sentence, that's our F. We give our degrees of freedom between and our degrees of freedom error. So if you recall, it's 2,21 equals, we give our obtained test statistic, which is 4.77. We know that P is less than alpha because it was significant. And if you're confused about that, definitely watch the video on determining P, significance of P related to alpha. And then we have to put our effect size, eta squared equals 0.31. So now we have given our overall ANOVA test result. But we have to give our post hoc test because this was significant. So this is where I put in a second sentence. Tukey, because we tell which one, post hoc tests showed that. This is where you have to be careful. You want to make sense of things. So I'm going to go back before we go further of things. So is what we could do is kind of culminate that in a sentence. So Tukey post hoc test showed that, and I'm going to put alcoholics, and now I'm going to put their mean, m equals 133.75, were able to maintain abstinence longer than smokers, their mean was 107.13, or heroin addicts. And their mean was 108.75. So notice these two means, the smokers and addicts, they're very similar. They weren't significantly different from each other. It was only their means compared to alcoholics that were significantly different. So now you've just gone through analysis of variance testing and how to write the results. Hopefully this was a good review, and if you have any questions, please pop into my office hours and I will help you with them.